Good morning, students. In today's class, we'll see about the classification of fluid flow. Classification of fluid flow can be classified into 6 types of fluid flow. So one is steady and unsteady flow, uniform and non-uniform flow, one-dimensional flow, two-dimensional and three-dimensional flows, laminar and turbulent flows, rotational and irrotational flows, compressible and incompressible flows of fluid. Steady and unsteady flow, in which the velocity of the fluid particles at any point is constant with respect to time. So dou u by dou t is equal to 0. In unsteady flow, this exists when the velocity at a point in the fluid changes with respect to time. So dou u by dou t is not equal to 0. Similarly, all other properties such as pressure dou p by dou t with respect to time is not equal to 0. So dou rho by dou t is not equal to 0. So the density, pressure or the velocity will change with respect to time is unsteady flow. In a steady flow, the velocity, pressure and the density will remain constant throughout the fluid flow. Next is uniform and non-uniform flow. This type of flow in which the velocity at a given time does not change with respect to space is called uniform flow. For example, dou v by dou s at constant time t is equal to 0. The flow through a straight prismatic conduit or flow through a straight pipe of given diameter is uniform throughout the session. Non-uniform flow. The flow in which the velocity at any given time changes with respect to space is called non-uniform flow. Flow through a non-prismatic conduit or dou v by dou s is not equal to 0 at constant time. One-dimensional, two-dimensional, three-dimensional flow. In one-dimensional flow, the flow in which the flow parameters such as velocity is a function of time with respect to x-axis or the one space coordinate only. For example, velocity at x-axis is f of x, v is equal to 0 and w is equal to 0, where u, v and w are the velocity components in x, y and z directions. Flow in a pipe where average flow parameters are considered for analysis. Two-dimensional flow, the flow in which the velocity is a function of time and two rectangular space coordinates is called two-dimensional flow. So that is nothing but u is equal to f1 into x comma y, v is equal to f2 into x comma y, and w is equal to 0, where u, v and w are velocity components in x, y and z directions respectively. Three-dimensional flow, the flow type in which the velocity is a function of time and three mutually perpendicular directions. U is equal to f1 of x comma y comma z, v is equal to f2 of x comma y comma z and w is equal to f3 of x comma y comma z, where u, v and w are velocity components in x comma y comma and z directions. The flow in a converging or diverging pipe or a channel. Flow in a prismatic open channel in which the width and the water depth are of the same order of magnitude. Turbulent and laminar flow. So laminar flow in which the velocity is constant or the flow of fluid layer will not disturb the other layer. It will be a streamline flow in which the path taken by the individual particle do not cross one another and move along well-defined path. Flow through a capillary tube or flow of blood in veins, arteries and groundwater flow. Turbulent flow is an example of unsteady flow and occurs when the sharp obstacles or bends in the path of fast moving fluid So a zigzag movement will be there. So high velocity flow in a conduit of large size. Compressible and incompressible fluid. It is a type of flow in which the density of the fluid changes from point to point. So density is not equal to a constant in compressible flow. So at high pressure, the density may change. For example, if you take an example of gases, so when it is compressed in a high pressure, so it can be bottled in a cylinder, so in which the density will be varying. Incompressible flow, it is that type of flow in which the density is constant for fluid flow. So under high pressure also, the liquids are generally considered flowing incompressible. So rho is equal to constant. Thank you.